In the far north, wildfires are breaking old patterns. Satellite data show that wildland fires once scattered across the Arctic are now surging in numbers, particularly in northern Eurasia, and many are burning more intensely than before. For millennia, this icy realm has been a bastion of cold, where fire seemed an intruder from warmer worlds. But now, the flames are awakening. Wildfires, once rare and scattered, are surging in number, size, and ferocity. They devour ancient forests, release buried carbon, and reshape the very fabric of our planet's climate. This is the story of the Arctic's changing fire regime, a tale of warming skies, shifting storms, and a landscape on the brink. To understand this transformation, we must journey back in time. The Arctic, defined roughly as the region north of 60 degrees latitude, encompasses vast stretches of tundra, boreal forests, and permafrost-laden soils. For centuries, indigenous peoples like the Inuit, Sami, and Gwich'in have lived in harmony with this environment, where fires were occasional events sparked by lightning or rare human activity. Historical records from Russian explorers in the 1700s and European whalers in the 1800s mention sporadic blazes, but they were contained by the region's inherent wetness, permafrost acting as a natural barrier, locking moisture in the ground. But data from the past few decades paints a starkly different picture. Since the turn of the millennium, satellites have been our eyes in the sky, revealing a dramatic escalation. NASA's Moderate Resolution Imaging Spectroradiometer, or MODIS, instruments aboard the Terra satellite launched in 1999, and Aqua satellite launched in 2002, have detected millions of fire hotspots. From 2002 to 2012, fires dotted the landscape sporadically, with clusters in Alaska, Canada, and Siberia. Yet, from 2012 to 2024, the detections exploded, particularly in northern Eurasia, where orange hotspots on maps now dominate like a spreading rash. These maps, courtesy of NASA's Fire Information for Resource Management System, tell a compelling story. In the 2000s, fires north of 60 degrees were balanced between North America and Eurasia. But starting in the early 2010s, Eurasia saw a skyrocketing surge. Siberia's vast taiga forests, once resilient, now burn with unprecedented vigor. Even Greenland, that icy sentinel, entered a new fire era. In 2015, satellites captured unusual blazes near Kangerlussuaq, scorching tundra that hadn't burned in recorded history. Then came 2017. A massive fire near Sisimiut burned over 2,000 hectares, releasing smoke that blanketed parts of Europe. And in 2019, another outbreak near Nuuk highlighted the island's vulnerability, though these fires remain too sparse to show on broad maps. Why this shift? The answer lies in the Arctic's accelerating climate crisis. According to the 2025 report by the Arctic Monitoring and Assessment Program, a MAP, a working group of the Arctic Council, the region is warming 3 to 4 times faster than the global average. Between 1979 and 2023, Arctic annual air temperatures rose by 3 degrees Celsius compared to a global rise of about 1 degree Celsius. This Arctic amplification is driven by feedback loops. Melting sea ice exposes darker ocean waters that absorb more sunlight, amplifying heat. Reduced snow cover in spring exposes soil to earlier drying. Jessica McCarty, Deputy Earth Science Division Chief at NASA's Ames Research Center, in an interview in 2025, fire has always been a part of the boreal and Arctic landscape, but now it's starting to act in more extreme ways that mimic what we've seen in temperate and tropical areas. We're seeing fires burn earlier in the year, late March instead of June, and persist after the first snows. In places like Siberia, areas are burning 2, 3, even 5 times in a decade. These ecosystems can't recover fast enough. McCarty, lead author of the AMAP report, emphasizes that rising temperatures dry out vegetation, turning mosses, shrubs, and ancient peat into tinder. But temperature alone isn't the culprit. Lightning, the spark that ignites 90% of Arctic fires, is migrating poleward. A 2022 study in Nature Climate Change found that lightning strikes in the Arctic increased by 300% since the 1970s, fueled by warmer air holding more moisture, leading to thunderstorms at latitudes once too cold for them. The Boreal forest, or taiga, spans 17 million square kilometers across the Arctic, home to spruce, pine, and larch trees adapted to periodic low-intensity fires. These surface fires clear underbrush without killing mature trees, promoting regeneration. But with climate change, we're seeing crown fires blazes that leap into treetops, fueled by drier conditions and stronger winds. Radiative forcing from these intense burns alters local weather, creating pyrocumulus clouds that can spawn more lightning. Specific events underscore this trend. Take 2019. Siberia's wildfires burned 4.3 million hectares, releasing 182 million tons of CO2, equivalent to the annual emissions of 36 million cars. Satellites like MODIS captured the inferno, with smoke plumes circling the globe, dimming skies as far as the United States Midwest. Then 2020, another record, with 5.6 million hectares scorched in Russia's Yakutia region, emitting 60 million metric tons of carbon. These fires weren't just big, they were hot. NASA's Suomi NPP satellite's VIAR-RS instrument measured fire radiative power values exceeding 500 megawatts per pixel, indicating extreme intensity. North America hasn't escaped. Canada's 2023 wildfire season was apocalyptic. 18.5 million hectares, burned 6 times the annual average since 2001. Fires in Quebec and Alberta forced the evacuation of over 232,000 people, with smoke choking New York City, turning skies orange on the 7th of June 2023. The Jasper Fire in Alberta alone burned 32,000 hectares in July 2024. Attribution studies from World Weather Attribution linked these to climate change. The probability of such extremes has tripled since pre-industrial times. Brendan Rogers, senior scientist at Woodwell Climate Research Center, notes, "Across the decades, we're averaging about double the burned area in the North American Arctic compared to the mid-20th century." His research, published in Nature in 2023, shows burned area in Alaska doubled from 1950 to 2000 and 2000 to 2020. But the fire's impacts extend far beyond charred trees. Arctic soils hold 1,700 billion tons of carbon, twice the amount in the atmosphere. When fires burn deep into peat and permafrost, they release this zombie carbon. In 2021, Arctic fires emitted 200 million tons of CO2, a third of global wildfire emissions. This accelerates warming. A 2024 study in Science Advances estimates that permafrost thaw from fires could release 100 to 200 gigatons of carbon by 2100 under high emission scenarios. Permafrost thaw also rusts rivers. As iron-rich soils mobilize, waterways like Alaska's Tanana River turn orange, as seen in 2023 satellite images. This alters aquatic ecosystems, poisoning fish with metals and acidity. Ecosystems suffer profoundly. Boreal forests, habitat for caribou, wolves, and migratory birds, face regime shifts. Fires kill lichen, a key caribou food, leading to population declines of 50% in some herds since 2000. In Greenland, 2017 fires scorched rare Arctic flora, threatening endemic species. Tundra fires, like those in Russia's Taimyr Peninsula in 2021, convert shrublands to grasslands, reducing biodiversity. Human impacts are dire. Indigenous communities, reliant on hunting and fishing, face food insecurity. In 2022, Alaska's wildfires destroyed 12,000 square kilometers, triple the average, displacing Gwich'in villages. Smoke from 2023 Canadian fires caused respiratory issues with PM2.5. Levels in Ottawa spiking to 400 micrograms per cubic meter on the 25th of June 2023, 10 times safe limits. Globally, wildfire smoke transports mercury and VOCs, affecting air quality even in the tropics. The 2024 to 2025 fire season continued the trend. In Canada, over 4 million hectares burned by July 2024, the second worst start on record. South America's lynx. Drought-driven Amazon fires in 2024 mirrored Arctic patterns, with Bolivia seeing record emissions. Expert interview. Tatiana Loboda, University of Maryland, in an interview says, "It's concerning how frequently these fires burn the same place. A lot of areas now burn 2, 3, or even 5 times during a very short period. It's an immense impact, happening across tundra and boreal regions, and these areas can't recover. Forecasting the future is grim." The IPCC's 2021 report projects Arctic fire seasons lengthening by 30 to 50 days by 2100. Under SSP 3-7, 23-like seasons, Canada's 2023-like seasons could occur 6 to 10 times more frequently. AMAP's 2025 update warns of tipping points. If permafrost carbon release hits 50 gigatons by 2050, it could add 0.5 degrees Celsius to global warming. Yet, hope flickers. Mitigation strategies include indigenous fire management, controlled burns by Sami in Scandinavia since the 1500s. Satellite tech, like FIRMS, enables early detection. In 2024, it alerted to 50,000 hotspots in real time. International efforts. The Arctic Council's Wildland Fire Initiative, launched in 2023, promotes cross-border cooperation. Reducing global emissions via Paris Agreement targets could have projected fire increases. The Arctic's flames are a warning, a beacon urging action. Ecological and human impacts. Beyond the climate implications, Arctic fires have profound effects on ecosystems and human communities. These impacts range from immediate and localized to long-term and global. For Arctic ecosystems, fire represents a fundamental disturbance that can reshape landscapes for decades or centuries. Many Arctic and boreal species are adapted to fire, but to fire occurring at historical frequencies and intensities. When fire regimes change dramatically, ecosystems struggle to adapt. Boreal forests can recover from fire, but recovery takes time. After a severe fire, it may take 50 to 100 years for a forest to return to its pre-fire structure. If the same area burns again after only 10 or 20 years, the forest may not recover at all, potentially transitioning to shrubland or grassland. These ecosystem transitions have cascading effects on wildlife. Species that depend on mature forests lose habitat. The timing of fire early versus late in the growing season affects wildlife differently, with spring fires potentially destroying nests and killing young animals. Caribou and reindeer, critical species for both ecosystems and human communities in the Arctic, are particularly vulnerable. These animals depend on lichens that grow slowly and are consumed by fire. After a severe fire, it can take 40 to 60 years for lichen communities to recover, creating long-term habitat impacts. The smoke from Arctic fires poses serious health risks to human populations. While the fires themselves often burn in remote areas, smoke travels widely. Indigenous communities in small towns across the Arctic increasingly experience severe smoke events during summer months. Poor air quality affects respiratory health, cardiovascular health, and overall well-being. Vulnerable populations, children, elderly, and those with existing health conditions face the greatest risks. In some Arctic communities, smoke events now occur every summer, fundamentally changing the character of the season. Infrastructure in Arctic regions faces increasing fire risk. Communities, roads, pipelines, and other facilities built in areas that historically had low fire risk now find themselves in fire-prone landscapes. The costs of protecting infrastructure and responding to fires near communities are substantial and growing. Our understanding of Arctic fire comes primarily from the 2025 report published by the Arctic Monitoring and Assessment Program, a working group of the Arctic Council. This comprehensive assessment synthesizes decades of research and satellite observations. The key findings are clear and concerning. Fire activity north of 60 degrees latitude has increased dramatically, particularly in Eurasia. Fires are burning larger areas with greater intensity and for longer durations than in previous decades. The geographic distribution of fires is expanding northward into regions with little fire history. NASA's Earth science teams have been instrumental in documenting these changes. The MODIS sensors on Aqua and Terra satellites have provided an unbroken record of fire detection since 2000, allowing researchers to track trends with unprecedented precision. Fire has always been a natural part of boreal and Arctic landscapes. For thousands of years, lightning-ignited fires have shaped ecosystems, influenced species distributions, and participated in natural carbon cycles. This historical fire regime was characterized by relatively infrequent fires burning at moderate intensities with long periods between successive burns in any given area. That regime is now changing. What we're witnessing is not the presence of fire in the Arctic, that's nothing new, but rather a fundamental shift in fire frequency, intensity, geographic extent, and ecological impact. The current trends are clear. If Arctic warming continues at its present pace, fire activity will almost certainly continue to increase. Climate models project that by mid-century, Arctic fire could be 2 to 4 times more common than it is today. By the end of the century, some regions could experience fire regimes more similar to current temperate forests than to historical Arctic conditions. NASA's satellites will continue to watch, researchers will continue to analyze, communities will continue to adapt. But the fundamental reality is clear. The Arctic is entering a new era, one where fire plays a far larger role than in the past. This is not a distant future concern, it's happening now. As Jessica McCarty says, we're at a crossroads. By understanding these fires, we can forge a path to preservation. Thank you for watching this scientific overview. Subscribe for more updates on space missions, and share your thoughts in the comments below.